Hey, what's up guys, my name is Cherno. Welcome back to Optimization October. Yes, it's still happening. In fact, I've been so slow with just getting everything up and running for Optimization October that I think it's gonna bleed well into November, but we're still going to get through everything that I have planned. So don't worry, October's just a number. That doesn't make any sense. My goal for this month is to try and optimize Hazel as much as possible in terms of both workflow and performance. So before we get to like the performance optimizations and trying to make the game engine run like a lot faster, because as we know, there are some serious flaws there, it makes more sense to start off with like the workflow optimizations, I guess, because once we kind of fix those areas, we'll have a better idea of what code needs to be optimized. No point optimizing code if you're then just gonna rip it out and rewrite it anyway. So for those of you who haven't been following along too much, I've basically started making a game in Hazel. It's called like, I don't know, Project Orange for now. Actually, I released a YouTube short about it recently, my very first YouTube short, but it's a single video. Anyway, I'll have it linked up there if you want to check it out. It's like 30 seconds long. Go and watch it. But basically what I've been doing is live streaming myself working on a game in Hazel. Pretty much all the work that goes into that game is entirely live streamed. And we're making this game to try and point out and like highlight some of the performance issues in Hazel, as well as some of like the workflow issues. And one thing that we found so far, one of the systems that I had to extend in Hazel was the whole mesh system, basically, because one of the features of the game is that a cube like flies down from the sky and then it fractures into all of these like different pieces. And that wasn't really easily possible to do in Hazel with the way that the mesh kind of workflow currently worked. And so I had to like change it. I mean, it was still possible, but it was like really, really difficult. Let's take a look at what the existing kind of workflow was like. So basically, I've just got a blank scene here. If we have a mesh, such as this fractured cube mesh, this is what was shown in that kind of YouTube shorts, that's what we see. We basically have like this pre-fractured cube, which is split into all of these different pieces. Now, the way this was made is pretty simple. You can just create a cube in Blender, or just don't delete the default one, and then fracture it using the included add-on. This creates like all of these different pieces. So if we export this cube as an FBX and then try and drag it into here, we are greeted with this kind of like import dialog. So what this is very similar to like in Unreal Engine or in Unity. If you drag an FBX file into like the content browser, you kind of have all of these import settings. In Hazel, it works a little bit differently. All you have to do is basically export the mesh into someplace inside your assets directory. So if we look at this physical like assets directory, you can see we just have an FBX file and I've just exported it from Blender right into this directory. So it automatically appears here and then I can drag it into the scene. But because I'm dragging an FBX file into the scene, this is something that is called a mesh source file. Now it used to be called mesh asset, but then I realized that was a terrible idea because it's a mesh asset. And then we also have just a regular mesh asset. So mesh asset and mesh asset, well, nightmare, right? So now it's a mesh source asset and a mesh asset, the two different things. So what this mesh source is it's like the source geometry for the mesh. So this is like an FBX file, a GLTF file, GLB file, you know, that kind of thing. Now from there, to use it in Hazel, you have to create like a Hazel mesh out of it. Now a Hazel mesh is, it doesn't like take all of the data from the mesh source and copy it over or nothing like that. All it is basically some metadata for the actual mesh, which dictates how you use it. So for example, you can select like a subset of submeshes and control various other like import settings that you would see in like, you know, a regular like Unity or Unreal Engine import dialog. That is all it is for the editor side of things. So while you're working on your game, it still refers to this source asset. That way you can easily like replace it with another FBX file if you want to, or if you tweak some settings in Blender and then export it again, it will all carry across. But then the plan is, this doesn't exist yet, but the plan is that when you package your game and you build it and you actually like use Hazel's runtime, that Hazel mesh file will actually take all of the FBX data that it needs based on what you've used, and then it's gonna basically convert it into like a runtime format that will be much more optimized for actual like Hazel's runtime compared to like an FBX file, which is really only good for editing and, you know, authoring your scenes, I guess, and your content. So the current import dialog looked like this. All it does is it lets you kind of create this HMesh file somewhere. Now I haven't actually given this scene a name, so this is called untitled scene, but I can put it anywhere I want. It's a .hmesh file. And then I can just hit like create, and you can see that it pops up over here. And then if I take a look at assets and meshes, which were created, if I just refresh this, you can see that it's, I also have a cube file that I used to make this ground plane. Then just going to fix the shadow settings a bit because they look awful. So what I have down here is this single fractured cube. Now, if I open this externally, which basically just means like in whatever the default Windows program is, it'll open in VS Code, and you can see what this file is. This is the entire like Hazel mesh file. It has this asset handle, which has since been removed because it's completely redundant, but it's got a link to a mesh asset, which is a mesh source. All of this, the stuff that I'm showing you right now, is the old workflow. That's why it's like it's a little kind of messy, and there's some things obviously here that have been removed and all that, but this is like the old kind of workflow, right? So you just have a link to that FBX file. This is that FBX file. If I open up the asset manager, and if we were to like copy and paste this ID in here, you can see that this ID is in fact a mesh asset, which is a mesh source, and then here is the file path, right? So that is what it's linking to. And over here, you have the ability to specify a subset of what you want to use. So again, and you can double click this to edit more specific stuff, but you can see that what it's actually created when I've dragged this in. And now, by the way, now that I've got this kind of mesh file, I don't have to re-import it, although I can. If I go back to like the mesh source, I can actually drag this in again and create another version of it, which is just like a different Hazel mesh file, but it's still referencing that same underlying FBX. That's totally fine, because you could, of course, want variants of that same mesh. However, if I take this mesh and I just drag it in, well, it's just going to drag it into my scene. Now I've got two. This is pretty, this is pretty much what you would expect, I guess. But anyway, with this specific cube here, though, what it's done is it's just created a single entity out of it, and we see that we have the mesh over here. It's got a mesh component. This is the actual like fractured cube mesh that we're referring to. That's what it's done. Now, internally, when it's imported that FBX file, which as we saw over here, hopefully that's visible enough, but it's got all of these different sub-meshes, or all of these different like meshes, I guess, in the hierarchy. It's actually just flattened that hierarchy, calculated all of the transforms, done all of that stuff, and then essentially kind of optimized it for rendering, because like we don't need to worry about traversing like the node hierarchy or all of that stuff for rendering. If we can just flatten everything, we can literally just iterate over like a vector, an array, and then just render all of these pieces. So they're still rendered as separate submeshes as far as the render is concerned. So that gives us the ability to have different materials for them, of course, and all of that important stuff. But if I was to kind of basically, let's see, if I visualize like all the different draw calls the renderer is going through, you can see that as I scrub through the draw calls, which I'm doing right where the face cam is, it's rendering these pieces all as separate pieces. So they're still separate submeshes. It's just that like from the gameplay side of things, I guess, it's just a single entity and a single mesh. Why is that an issue? Well, it's an issue because if we wanted this to somehow be dynamic, not just a static mesh, so in this case, I've got a fractured cube, but I could have the entire Sponza model, for example. That you can imagine, you'd probably want that to be a static mesh in the sense that like, you know, it might be different, it might be made up of different sub-meshes, different materials, different transforms, all of that stuff. There might be several meshes there, of course, but it's still just like level geometry that you want to keep as just static geometry. You just want it to be rendered, and I guess you might want like physics colliders on it, but you don't need it to behave as like each piece to behave as like a separate entity in your game. With this though, the idea is this cube like kind of falls out of the sky and then it breaks apart into pieces. So for that to work properly with the physics system, we kind of need to have each piece be its own entity, and each piece to be like its own rigid body, and it needs to exist within like the actual Hazel scene as separate pieces. So how do we achieve this? And the answer is you basically can't with the current system, right? The only thing you can do as a workaround is if I go back to this, I can just say that like, well, you know, let's just use one piece of this. And then if I reload this, you can see it's now got one piece. I can also specify, like, as I mentioned, a subset of these submesh indices to have several pieces. And then I could basically make, there's 20 of these, 20 pieces. So I could make 20 copies of this fractured cube mesh, drag them all into separate entities, and basically replicate this whole hierarchy myself. That's awful. What we want to do, basically, and the solution that I kind of came up with was to have two different types of meshes. And this is kind of similar to how other engines work, of course, but I think it's a little bit slightly different. We can basically have two types of meshes, dynamic and static. Now, something like Unreal Engine has, like, I guess, static meshes, and then it has like skeletal meshes. It's kind of similar to that, I guess. Basically, my plan was to just take this mesh asset, and when we create it, when we create like an instance of it, kind of, we can specify whether or not we want it to be a static mesh. And a static mesh would behave exactly like I've just shown you, right? We can basically just treat the whole mesh as a single entity, and it's intended to be used for things like level geometry, or whenever we kind of want to still have maybe separate submeshes here in the actual file, but we don't care about retaining them as separate entities and saving their transforms and all of that stuff, because we're not going to be manipulating this during the runtime. It's just something that exists like maybe internally, and we can happily flatten that hierarchy and just kind of, you know, add a physics collider to it, sure, so that you can kind of like walk on that level surface and collide with the walls and stuff, but it's not going to be treated as like this dynamic entity. Or if you uncheck the during the import dialog, if you uncheck static, then what it would do is actually replicate that entire entity hierarchy, well, rather the mesh hierarchy. So this hierarchy that we have here, if we go through like all of these different pieces, then you can see that like they have different transforms. Obviously, we haven't like, you know, we haven't baked these transforms in to the actual vertex buffer, into the vertex positions. The actual like nodes here in this node hierarchy, they have a transform. And the idea would be to actually create a series of entities here that would not only render a single submesh, but also they would effectively be like a single node, even if we had like empty nodes here without geometry for whatever reason, right? Because we might want that for manipulation, like during runtime and all of that stuff. It would create a single entity with that node transform and with a single submesh that we would render, and the hierarchy would be properly replicated here, so that we could then like essentially treat that mesh inside Hazel, inside our game, as if it was just this kind of hierarchy and structure within Blender. And obviously that would work for our cube shattering, because we would just have every piece be its own rigid body in the physics system. It would be like a convex rigid body, and then, you know, we can just drop it out of the sky and it's done. Like, it would just work because they're all separated. And that is basically the overview of this like entire task. I went a little bit deeper into this just so that you would understand the problem. I find that, like, you know, there's a lot of workflows, there's a lot of optimization kind of solutions out there, but honestly, in my experience, it's just as important to understand the problem. Because if you don't understand the problem, even if you know, like someone's told you, you know, do this to make something fast, or you have to do a workflow a particular way, that might not click unless you have actually like lived through the problem yourself and you see why it's a problem. I think this really applies to like optimization. You know, we're kind of like taught as programmers that certain things are slow, but it's just so much more powerful in my experience to see that slowness yourself, you know, to profile it, to see that, and then to implement like a solution and benchmark it and profile it and test it and see like what a difference that makes. I think that that's so useful, you know, when you're learning. And so hopefully my kind of intention with this kind of Optimization October is to show you that kind of before and after for both workflows and performance. Okay, so let's dive into the current state of things in Hazel. So I've actually got two Hazels running now at the same time. This is like the mesh branch, which is like where I've started doing all of this mesh workflow stuff. And this is actually Project Orange, which is hard to see, but over here, as you can see, this is the orange project. So for those of you who want a little bit of context, we basically have like these orange cubes falling out of the sky, and then you can see when they land, they kind of explode into all these pieces. And in fact, we can even, when they spawn, we can even actually like shoot them out of the sky by just like clicking on them like that, right? And we can like shoot all of these various pieces as well, which is pretty cool. So how does this work, and how does this kind of integrate with the new mesh workflow? So the idea in the beginning is basically the same. We have this fractured cube. You can see it's been renamed to mesh source now. I can drag this into the scene, and now basically all I have, really the only difference in these import settings so far is that I have this static checkbox. I can make it a static mesh, or I can make it a non-static mesh. So you can see that the extension changes as well. A static mesh is currently known as like an HS mesh, so a Hazel static mesh, whereas this is just a Hazel mesh. I didn't really want to call them dynamic meshes. They're just called regular meshes, I guess, just mesh. But the static meshes are always known as static meshes. So let's create like a static mesh out of it. So I'll just put this into like demo, and we'll call it fractured cube, and this will be a static mesh. So if I create this, if I go back out here, I made a little demo folder, and then here it is, a static mesh. So if I drag this out into the scene, you can see that this is basically the identical like workflow to what we had before. But the only thing that's changed is that this particular cube, as opposed to like, oh, I've got another one here. Did I create two, or was that one always there? That's weird. Anyway, there should be only one of these, but you can see that it's a static mesh, right? So we have two different components. We have a static mesh component. We can still like override materials and stuff, but there's only one material slot in this mesh, but it's a static mesh. And usually what happens with static meshes is that we can add like a mesh collider to it if we want. Now, I think at one point it was automatically adding mesh colliders. I'm not sure why it didn't when we dragged in here. Maybe that's something that I need to change, but we now have this kind of mesh collider here. And what it does is, because it's a static mesh, it will create a triangle mesh collider from it, from PhysX. Now, that means that it can't be dynamic, but we can have like, you know, concave kind of geometry, and it doesn't need to be like a convex hull or anything like that for it to actually be like a dynamic rigid body. And then this, you know, so we can still kind of use this workflow for if we wanted like a level and we wanted it to all be static, and we can get pretty, you know, pretty good collision with that as well. But it's obviously just a static mesh, and it's obviously just one entity. Now let's compare this to what it would be like if we wanted this to be dynamic. So the only difference is we drag in this like mesh source, but this time I will unmark static, and I'll put it into that demo folder as well. Let's hit create. And then, oh, right, there were two last time, because by dragging this in, it will also create it in your scene. You don't have to go back and you know, and drag this in manually. So that's why we had two last time. But you can see what it's done is it's made what looks like the same thing. But if you look in the hierarchy, right, this one over here, it's actually got that entire like Blender hierarchy replicated over here. And these pieces are all kind of individual pieces, which we can click to select, and we can, you know, drag them out and all of that. That stuff all kind of works as you would expect. And they have also, if you look over here, they also are entities with mesh components, not static mesh components, just mesh components. And over here, we have a rigid body applied to them as well. And that's cool, because if I hit this button to simulate physics, you can see that it will fall and it'll shatter, right? So this is actually like all entirely dynamic physics versus this thing over here. You can see it's not going to fall. Now, if I take this kind of parent entity, which is like the whole object, I move it over like here or something, because we added a mesh collider to this, it's a triangle mesh collider, we can also simulate physics on it, and that should work as expected. Although now we've got this thing here. So yeah, work in progress, but this kind of new mesh workflow enables us to actually make those cubes falling down and fracturing in a much easier way. I mean, honestly, there are so many features that I've wanted to add to Hazel, not just like refining workflows, but for example, like, you know, we're shooting, so wouldn't it be nice to have little particle systems like sparks appear when we hit a surface, or decals, so that we can actually like, you know, have bullet holes in the walls. There's so many different things that I've wanted to add, but I have to stop myself, because this month, and honestly, not even this month, probably next month as well, until I get through my massive list of tasks, we are focusing on refining, optimization, all that stuff. And I think it's kind of a nice approach, and it's a nice kind of, I mean, it's honestly just quite nice to take a step back and do that, because there is massive satisfaction in refinement and, you know, being able to take a step back and actually process all of this stuff is both beneficial to the engine, but also it's kind of forcing me to actually think about the architecture and like what it is that I'm building, and try and improve that as much as possible. Because sometimes you can get lost in just jamming, you know, feature after feature, and you kind of begin to create like a worse product, and that's definitely not what I want to happen with Hazel. So I'm gonna keep kind of evolving this game. I think even past optimization October/November, you know, once we get past all that, I'll still kind of keep this game, this Project Orange thing, as like, you know, hopefully something that we can kind of just build up over time. I might actually start posting some of the live streams here on this channel, or edit them down or something, so that you guys can kind of see the evolution of this game and just keep up with its development, really. Let me know in the comment section below if that's something that you would want to see. Otherwise, thank you guys for watching this video. Please don't forget to hit the like button. Patreon.com/thecherno, best way to help support Hazel, this channel, all the videos that I make, all of that kind of stuff. You'll get access to this. I haven't made Project Orange available yet to patrons, but that's something that I intend on doing pretty soon. Let me know what kind of videos you would like to see on this whole optimization kind of topic. You know, my plan is basically, as I go through every item on the list, so this is an example, we did like mesh workflows today. As I go through every item on the list, I plan on making a video that kind of, you know, documents that process and like what I found and all that stuff. I think it'll get a little bit more technical when we get to the optimization stuff, because this is mostly just workflow and it's not that difficult, hopefully, for you guys to see how it works. It's probably a little bit more informative for me to talk about it from a higher level like I did today, rather than showing you code of, you know, Hazel specific code and all of that. Although if you do want to take a look at the code, of course, you can get access on Patreon. But now that Hazel supports this new mesh workflow and we can actually get this game going, the next step is probably going to, you know, focus on optimizing the actual performance. So whether that be like the actual renderer or how prefabs get instantiated, the whole relation like with the scripting engine and with C#, that needs to be profiled and optimized a little bit more. But the other thing I really want to take a look at is shadows, because there are some basically low-hanging fruit that we can actually tend to. There are basically just some bugs to do with that system that should take like 10 minutes to fix, honestly. So I might take a look at that. Thank you guys for watching. Have a great rest of your day, and I will see you next time. Goodbye.